Okay, the first mounting on a tree that I was able to shoot a line over a limb on. And it wasn't very high. You can see a chain link fence right below it. But that's where I first started using it. And now we go into this, which is why build a J-pole. And as I say here, I was quite pleased, really, in spite of what Pete said, with the 2-meter J-pole that I was using. I just needed one for 10 meters. And one reason is I was taking part in the 10-meter net, and I needed something omnidirectional because I didn't really know in what direction all of the participants were located, and I didn't have provisions for rotating even if I did know. So omnidirectional seemed the way to go. Second thing, yes, I was pleased with the behavior of the 2-meter J-pole, which actually works from the back stairs inside the house. I don't even have to worry about lightning with that one. The other one is a bit more exposed, obviously. Anyway, I looked around and there didn't seem to be anybody selling commercially built 10-meter J-poles. So I went to what I wanted to do anyway, which is use my machine shop. Build one from scratch. Now most J-poles you see are what are called the copper cactus, made from copper plumbing. But I figured that the 10-meter one was going to be a bit heavy, made all of copper, so I ordered a bunch of aluminum stock from various sources. But first off, I found a website that had a set of formulas showing the proper length for a J-pole for any frequency. And the site, I've got it at the bottom, but I don't think many of you can see. It was www.hamuniverse.com/jpole.html. Got to give credit where it's due. Anyway, we get flashes of length from the side arm to the end of the long element with that formula, 705 divided by the frequency in megahertz. The shorter element, 234 divided by frequency in megahertz. Spacing between the elements, 22 divided by the frequency in megahertz. And then finally, how high up the pickoff sliders are on the two elements, which is 23 divided by the frequency in megahertz. So that's the dimensions. Their web-based calculator told me 24.79 feet. As somebody used to doing machining, that didn't seem like enough decimal places. So I hauled out the HP15 calculator and took it to 4 decimal places, 24.785 feet. Now, no, I couldn't measure quite to that precision for the full length, but you know, have as much detail as I can. And while we're about it, with the I also calculated it in feet and decimal fractions of inches, or feet and decimal fractions of feet. And, yeah, just a few more button presses, so why not? Here is the first of the stock. The one on the right, 2-inch by 1-inch aluminum bar stock, and that was used to make the horizontal part that joins the two elements. Of course it's too long. It was long enough to make 3 of them. As it turned out, it was good to have enough to make 2 of them. We'll get into that in a bit. The next item there is 1/4 inch thick, but still 2 inches wide. That was used to make the sliding elements that bring the taps into the main elements. And then this last one is Delrin, insulating. I figured that this was going to be a rather whippy thing and difficult to mount by its base and keep stable. So I designed in and made an attachment at the top end of the pole to insulate it from rope hauling it up into whatever tree I could press into service. Okay, here's the whole bar of 1 by 2 inch painted with blue layout dye. That's because I could find the blue layout dye and the red layout dye was hiding, but red is better for working with aluminum. So I put that comment there, and Pete was helping me set up this presentation, and he likes fancy things, so next thing you know, that's red. Okay. Anyway, here's all the elements. The tubular elements came from Texas Towers. Longest they had was 6 foot. I needed a lot more than 6 foot. But anyway, the bottom one is 7/8 inch. The next several are 1 inch. The 7/8 inch slides very smoothly into that. Then a 5/8 and a 1/2 inch for the shorter element, with more of the 1 inchers hiding behind them. There was a limit to how much I could spread it out and still photograph it. Oh, that goes on and tells about it. Yes, it says I have 5 pieces of the 1 inch. And close up with annotation on there. Okay, that's some Lexan left over from another project and cut down to make spacers. Because this thing is long and it's going to be whippy. I didn't want the spacing between the elements changing with breeze. So, insulating spacers. Okay, now because those 6 foot lengths weren't enough, I had to have a way of splicing it. So this is the 7/8 inch. A piece of it cut to 8 inches long, the mark for the middle point, and that other thing, the hex thing there, is a drilling jig, so I can put 3 holes at precise 120-degree intervals around it. Here it's slid on, the tubing is clamped into a V-block, and I measured the distance that extended from it. So this always puts the holes the same distance in from the end. First hole drilled, and then drive in, push in a pin so it holds position, and then rotate the thing and drill 2 more holes. There you can see 2 of the holes. Obviously the third one's hiding because 120 degrees does that to you. Okay, the 8-inch piece slid into its mark. First hole drilled through the existing hole and into it, and then put in a pop rivet. 3 of them around there to hold it, the other piece sliding on, and then I swapped in, so I was drilling at that end, so in case you're feeling reversed. But do the same thing, and that joins 2 pieces. 2 pieces would fit in my shop. 3 or more would not. So I postponed some of the drilling and joining till the time of final assembly outdoors.
Is your shop
what?
Is your shop in a linen closet or something?
No, it's a 2-car garage. But it's full of machine tools instead of cars.
So at this point, that's 12 feet long then, right?
Yes.
Okay.
And, I had to have it short enough so that I could rotate it and guide it out one of the doors. Anyway.
Did you put any conductive paste or anything inside?
I did not. I did not have any at the time, and I figured the force of the pop rivets would make a pretty airtight seal, especially since I was using a hydraulic rivet setter. Lucky enough to have. Anyway, this is the milling machine shown at a bit of an angle, drilling holes in the first crossbar. You note on the doomed workpiece, that's because I hit a problem that I'll mention later on. So here's the second one with the red dye, which I finally found, and you may or may not be able to see the fine lines for where the various holes are to be bored.
Why do you prefer red?
Red makes a better contrast with the aluminum color. Steel seems to work better with blue. That's the common knowledge in the machine shop world, so I go with it. Okay, back to the milling machine. 6-flute mill, making a lot of chips at the same time. For what it's worth, I had to bore a smaller hole first because the 6-flute mill is not center cutting. So I used something like a 7/8 inch, I think, to bore the first pass and make sure it would clear the solid center. Anyway, those chips are not the sort of thing to reach around when they're flapping. You can get all kinds of cuts. Anyway, all 3 holes bored. Then a bit more work. You noticed at the end some notches, slots that go all the way through and cut into the end holes. They are so it can be made to clamp down on the tubing. Here is it with holes drilled across and tapped and the clamp screws. And that's what happened to the first one. I tried using a roll tap, a thread forming tap rather than a cutting tap, and it broke off in there. And I spent a while trying to drill out with a special fancy carbide drill the remains of it, but I didn't get enough, so I trusted running another tap into it. So I went to this new piece. And I still had enough material left to make a third one just in case. Okay, then alcohol cleans off the layout die. Nice thing to know, because otherwise you're there for a while sanding and trying to get rid of it when you're done. There are the stainless steel screws up at the top and the Allen wrench that's used for tightening them. And I decided to mark it while I was about it. Number stamp. And again, Pete has slow moving lettering for me, but that's okay. Here it is now with the 2 insulating spacers. If you'll note, the upper one, the right-hand end, is smaller than the lower one. That's because the lower one clamps on the 1/2 inch, on the 5/8 inch, and the upper one clamps on the 1/2 inch tubing. Those 2 middle things are the sliding tabs. One connects the shield, and the other one connects the center conductor. And having that double-ended BMC seems like an easy way to accomplish the connection there. Okay, there is the insulating hanger from the top. The notches you see there, which increase the leakage path a bit, I decided they were a little too square, and I did bevel them with another tool, but I didn't remember to photograph it again after that, so that's what we have there. Okay, here it is.
What power are you going to be using on that?
100 watt. Well, that's the HF rig I have. I could probably go higher, but I don't know how much higher.
What's the breakdown voltage of those ventilations?
Hmm? it's not the power, the voltage from the power I was thinking about, but wind generating static charges during a storm. But anyway, here it is outdoors in an old Black & Decker workmate. Here it is all the way up to the top insulating spacer. Oh, if I remember, yes, conductive crossbar, insulating spacer, and other insulating spacer. And just a little bit past the handle there, you can see a change in diameter of the smaller one. That gives me the ability to adjust the length of it for tuning as needed. And the clamp at the bottom lets me adjust the main element. Okay, as you can see, it is a little bit flexible. That's 3 sections going out that way. And the hole in the middle of the crossbar is simply to feed the antenna cable in through, to keep it from flapping around a lot with the weather, with wind. Okay, here is where it was first hung from a tree across my driveway, and the highest limb I could get was not really high enough. But it was there, and I used it there for a while until I had a tree come down during windy weather a while back. And they, while they were there, the tree tilted over, threatening a storage barn, and hooked itself on another tree which was still in great condition. Had to get guys with cranes to take it down. And while they were there, I said, you know, you guys are pretty good working at heights. Could one of you fasten this pulley up on one of the high limbs on this remaining tree? They were glad to show off. So they did. And that gave me a lot more height to haul things up. If I remember right, I measured the bottom end of the antenna at something like 54 feet. Anyway, I also redesigned the choke ballad. Another website warned avoid scramble winding because you can wind up with voltage breakdown between adjacent turns. Wind it on a cylinder. I didn't have any cylinder big enough for a comfortable turning radius for the cable I was using. So what I did, I used a world supply of cable ties to space them out, form them into an approximate cylinder. Kept the ends and the beginnings well separated. Then, since those cable ties were not black and UV resistant, wrapped it to protect it from the UV for a while. Also, the information suggests you don't mount the balun any too close to conductive material. So I've got lengths of the Dacron rope to hold it below the crossbar and run the cable on down. There are the 2 slides in position, and that's probably the best view you'll get of those. And then I had to get the signal into the house. That's more of the Lexan that I used for those spacers before. Drilled, shallow grooves milled so that the length of the feed-through type ends wasn't pushing the nut out of reach of the threads. And 2 ground wires coming in, and all those dots to the left, I'll explain them in a moment. From the inside view. Oh, and also, here's the ground being fed out to 2 lightning arresters, and the others are going to be lightning arresters once I get more of them. But you've got a series of screws holding an extra Lexan plate on there, because I built the thing to have a tongue that would fit into the sliding groove on each side of the window. Found out that the thing was too stiff to bend and pop into place, so I cut it apart and made a splicing plate there, and so that's what did it. And that's it.